here's the situation. A tree is 2 feet tall and it grows 3 feet per year. All right, so after 0 years, what's the height of the tree? Well, it's 2 feet tall, right? It starts at 2 feet tall. Now, after 1 year, right? So the tree started at 2 feet tall, and then it's growing, it grows in that first year, grows 3 feet. So what's the height? Well, now it's 5 feet tall, right? Because it was 2 feet tall, and then in 1 year it grew 3 feet, so now it's 5 feet tall, 2 plus 3. What about after 2 years? Well, it started at 2 feet, right? And then it grew 3 feet that first year, and then it grew another 3 feet the next year. So I could add 2 plus 3 is 5, plus 3 is 8. I could also write this as multiplication, right? I could say this is 2 plus, and this 3 is multiplied by 2, right? I could say, oh, well, it grew 3 feet 2 times, right? For 2 years, it grew 3 feet each year. So I could do it this way, right? And this would be the same answer. This would be 2 times 3 is 6, plus 2 is 8. Now, what if I wanted to know how tall it was after 5 years? Well, then I would have to take, okay, that original 2 feet. Right now, I'm going to use repeated addition here in this box. I would say, okay, it grows 3 feet, plus another 3 feet, plus another 3 feet, plus another 3 feet, plus another 3 feet. That's 5 times, right? Because it's 5 years. I could also write, right? I could write this as a multiplication. I could write that is the same as this, right? This is, it grew 3 feet, right? 3 feet per year. It grew 3 feet 5 times in 5 years. So I would probably, right, I'd probably prefer to do this math. 5 times 3 is 15, plus 2 is 17. And after 10 years, let's not write the repeated addition, right? That just seems like a waste of time. That would be, it would grow 3 feet 10 times. So that would be 32 feet tall after 5 years, after 10 years, excuse me. So now I can take this situation and I can actually graph it, right? So these are actually points, right? This is 0, 2. This is after 1 year, it's 5 feet tall. After 2 years, it's 8 feet tall. After 5 years, the tree is 17 feet tall. After 10 years, the tree is 32 feet tall, right? So I can actually write these points, and this point has a meaning, right? This means like after 5 years, that X value represents years. The tree is 17 feet tall, right? Now look, the information is here. See the X value? This is number of years. So look, along the X-axis, I can even write number of years. Along the Y-axis, I can write height, right? This is the height of the tree. That's what my Y value is. Okay, so like this, right? This is saying if the X value is 5, that means after 5 years, number of years, then the height of the tree is 17 feet, right? This is height. This is height in feet. Okay, now look, I can graph these points, right? Here's 0, 2. Here's 1, 5. Here's 2, 8. Now look, I run out of graph, right? Like I don't have space to graph 5, 17, but it would be somewhere here. And you can already see that it's a straight line. And that line would continue, right? And that line would hit, 3, 11, and whatever it would hit. And that line would continue forever. Now, what's the equation of this line? Well, I can look at the graph and figure out the equation from there, right? I have the skills to do that. I could also, what I could do is I could use 2 points, right? And I could find the slope, and then I could solve and find the y-intercept. I could do that. Okay, I'm going to just look at the graph. And what I notice is that the y-intercept is 2. So if I'm writing, y equals mx plus b, I'm going to write y equals, and my y-intercept is 2, right? Remember, my y-intercept always goes here. This b is my y-intercept. And my slope, what's my slope? Well, my slope is my rise over run. So let's see, it's 1, 2, 3 up over 1. So that's 3 over 1, which is just 3. So here is my equation. Okay, y equals 3x plus 2. Y equals 3x plus 2 is my equation. That's the equation of this line. And in fact, I can check, and if I plug in an x value here, right, like this would be 3 times 5 plus 2. Does that equal 17? Yep, it sure does. Okay, so now, what does x equal? And we already kind of said this, right? But this is really important. X is the number of years. Okay, and y is the height. And you'll notice like I'm really kind of focusing on this idea of what does the x represent, what does the y represent. Now, here is where this becomes way shorter. What is the slope? The slope is 3. What is that? Where did that come from in the problem? It came from here. So this number tells me how is the tree changing each year, right? It's growing by 3 feet, okay? Now, this is what we use this term. It's called rate of change. That 3 tells me how is the tree changing? And rate means like how fast is something. So like how fast is the tree changing? Well, it's changing by 3 feet per year. Okay? Now the y-intercept in my equation is 2. Okay, where'd that 2 come from? It came from here. Now what was that? The tree started at 2 feet tall. Okay, so the y-intercept is the starting point. Now, here's the thing. This, what I just wrote right here, this is always going to be true. So this is going to help us go straight from a word problem to an equation a little bit more quickly. Let's do another one where we go through the whole process, and then hopefully you'll start to see some of the patterns and be able to pick up on some of the shortcuts that are here. Okay, let's take a look at this one. I'm going to move a little faster on this one. Jack had $9 and he spends $2 each day. So after 0 days, he has $9, right? Now, after a day, he's spent $2. He spent $2. So how much money does he have left? Well, so he started with 9. And if he spent $2, I'm actually going to take away $2, right? Which is 7. Now it says repeated addition, but this is like the same as 9 plus negative 2. Okay. Now after 2 days, he's had the $9 and he's taking away $2 the first day, taking $2 away the second day. He has 5. How could I represent this? Well, it would look like this. It would be, okay, the $9, right? And then he's subtracting 2 times. Okay, he's subtracting 2 times. Now, I'm going to start with $9 and I'm going to subtract 2 5 times. Right here I have $9. I'm going to subtract 2 5 times. Okay, now this becomes 9 minus 10, which is negative 1. Now, look, real life, this doesn't really make sense, right? After he runs out of money, he can't just keep spending. He can't just get negative money, okay? And the same is going to be true here, right? After 10 days, the thing is he actually doesn't have enough money to just keep spending $2 a day. And we're going to talk tomorrow about how we can avoid this situation where what we have is actually a negative result, which doesn't really work in real life. Okay, but again, I can say, okay, well, these are my points. Oops. And I can graph them. And again, not all of my points will fit on this graph. Okay, but I can graph 0, 9, and 1, 7, and 2, 5. And I can see when I sketch this line, right, that like after 3 days I'll have $3, and after 4 days I'll have $1. Okay, because this x-axis, right, is the number of days. And then this y-axis is my money, my number of dollars. Okay, now what's my equation here? Okay, now watch. I can use this graph. I can use 2 points. But I can also look and say, okay, well, I remember from my first example that the slope will be the rate of change and the y-intercept is the starting point. So when I go to write my equation, my y-intercept is the starting point. What did Jack start with? Well, he started with $9, positive 9, right? He started with positive $9. And then how did the amount of money he had change? Well, it went down by 2 each day. So that looks like this, okay? And I want to point out to you that looks, right? This is, I'm going to take negative 2, I'm going to multiply it by the number of days, right? I'm going to take negative 2, I'm going to multiply it by x, which is the number of days. And then I'm going to add 9, and that'll be the amount of money. Look, I'm going to take negative 2, I'm going to multiply it by the number of days, and then I'm going to add 9, and that's going to be the amount of money. And you can see that's actually what happened here. Okay, but once again, the slope is the rate of change, and the y-intercept is the starting point, right? In this case, Jack started with $9, and the amount of money he had changed by negative 2 each day. He lost $2 each day because he was spending money.